numbers through multiplication. Your learning goal is that I can compare two numbers by showing one as times as much as the other, or by showing one as a fraction of the other one. Here's an equation with two missing values. List several pairs of values that make the equation true. So something is equal to 4 times something else. Well, I know that 16 is equal to 4 times 4. Or I could have said 12 is equal to 4 times 3. Or maybe I might have said 20 is equal to 4 times 5. List several pairs of values that make the equation true. So another example would have been that 8 is equal to 4 times 2, and we're seeing here a visual representation or a model of that. We can also see that 36 is equal to 4 times 9. And again, we've got a visual model illustrating that. 40 and 10. 40 is equal to 4 times 10. No visual model this time, but we're pretty good now at multiplying a single digit by 10. For each pair of values, how many of the smaller value make up the larger value? In each of the previous problems, we were taking some number and multiplying it by 4. So 4 of the smaller value make up the larger value. How far apart is each pair of values from question 1a? For example, if we use the equation 8 is equal to 4 times 2, then it is 6 apart for 8 and 2. 36 and 9 were 27 apart. 40 and 10 were 30 apart. Jo is a vegetable farmer. Her crop this year has done much better than last year. Compared to last year, she has 3 times as many carrots, 5 times as many squash, 11 times as many beets, and 12 times as many cucumbers. That's really quite an improvement in her gardening abilities. How many of each vegetable might she have produced last year and this year? Use a chart like this to record your answers. So let's say that she had just 10 carrots. If we go back to the question, it says there's 3 times as many carrots. So there's 3 times as many carrots, 5 times as many squash, 11 times as many beets, and 12 times as many cucumbers. So if there's 3 times as many carrots this year, that means there will now be 30. If she had 100 squash, now she would have 500 squash. If she had 8 beets, now she's got 88 beets. If she had 8 cucumbers, now she has 96 cucumbers. We'll repeat the process again. This time we'll choose some different numbers: 90, 40, 100, and 70. So 3 times 90, 270. 5 times 40 is 200. 11 times 100 is 1100. And 12 times 70 is 840. Starting with the first example that we did, we're going to create a model, and I think I'll start off just with the carrots. I picked some pretty round numbers from the start, so let's focus just on the cucumbers here for this example. Fairly simple calculation then. 80 plus 16 gives us 96, which confirms the number that we've calculated. For question 3, we're asked to use the model from question 2 and write the fractions to show how last year's numbers compare to this year's numbers. So you can see that when we write them out this way, we've immediately got what looks to be a fraction, which we of course remember from our earlier lessons that a fraction is a division question. So 10 divided by 30, which can also be simplified to 1/3. 100 over 500, can scratch off the zeros, and we end up with 1/5. 8 divided by 88 is 1 over 11. We're dividing both the top and the bottom by 8, which gives us the fraction of 1/11. And 8 divided by 96 is 1 over 12. When you go back to our initial problem, we were told that we have 3 times as many carrots in the second year, 5 times as many squash, 11 times as many beets, and 12 times as many cucumbers. So you can see that these numbers all match up. Why are there so many possible pairs of values for each crop? Here's an example answer. For the carrots, the second number only had to be 3 times as much as the first number, and there are lots of number pairs like that. 1 and 3, 2 and 6, 3 and 9, number of possibilities are really infinite. If you had last year's numbers, how would you figure out this year's numbers? You're simply multiplying by 3, 5, 11, and 12. If you had this year's numbers, how would you figure out last year's numbers? Doing the reverse operation, you're dividing by 3, 5, 11, and 12, or you're finding 1/3, 1/5, 1/11, or 1/12 of this year's numbers. What do you notice about your answers to parts A and B? Here's an example. It's like saying the opposite thing. If you go one way to get bigger numbers, you multiply, but if you go the other way to get smaller numbers, you're going to divide. But you multiply or divide by the same number for each crop. Lesson summary. You can multiply or divide to compare two numbers. For example, you can compare 30 and 3 like this. Since 30 equals 10 times 3, then 30 is 10 times as much as 3. Since 30 divided by 3 equals 10, then 3 is 1/10 of 30. You can model how two numbers compare. For example, this model shows that 1/12 is 3 times as much as 4, since 12 is equal to 3 times 4. It also shows that 4 is 1/3 of 12, since 12 divided by 3 equals 4. So that's being illustrated here with the blocks, as you've got 3 groups of 4, and that's equal to, obviously, the group of 12 blocks below. This model shows that 12 is 4 times as much as 3, since 12 is equal to 4 times 3. It also shows that 3 is 1/4 of 12, since 12 divided by 4 is 3. So in this diagram, you can see that the 12 has been broken up into blocks of 3 this time. And that's the same as 10 plus a block of 2, which gives you obviously the 12. If you multiply one number to get another number, you divide to go in the other direction. For example, since 3 times 10 is equal to 30, then 30 divided by 10 is equal to 3, or 30 divided by 3 is equal to 10. Since 3 times 4 equals 12, then 12 divided by 4 equals 3, or 12 divided by 3 equals 4. Now it's your turn.